Very good evening to all. Today we are going to deal with analysis experiment. So your first experiment will be of beam analysis. So you can see now it's a simply supported beam in which two point loads is acting. The conditions are given as Young's modulus as 2.1 into 10 raised to 11 Newton per meter square and Poisson's ratio. These two are the material properties, and the cross section of the beam is given as 0.2 by 0.4 square meter. The total span of this simply supported beam is 14 meter. The first support to the first point load is 3 meter, and the second support to the second point load is 4.5 meter. So here we are using the software ABAQUS CAE. So first of all, you have to click on ABAQUS. You can search it from start menu. So this is the start session of ABAQUS CAE. So here you have to select with standard or explicit model. So you have to click standard or explicit model. So now, in order to carry out analysis, first you have to define your working directory. So you have to set the working directory from the file menu. From file menu you have the option set work directory. So click on that. The ABAQUS will launch a dialog box. So in that you have to point out where your working directory should be. So click on this icon. There you have to specify where your working directory is. So here I am specifying where my working directory is. Experiment 1. Okay, so this experiment 1 is my working directory. So select your folder, then click OK. Again click OK. So now you have set your working directory. So now we have to model the part. So this is your model. You have to prepare this model. For that, initially you have to start with the module part. Okay. So in that part module, you have to select create part. This is the first option in the model tree. So click on this create part. It will be asking the name of the part. Let it be beam 1. We are doing it as a 2D planar deformable type, and the base feature should be selected as wire. Approximate grid size is 200. Here we have to create the model by selecting the create lines connected. So click on the create lines connected. We are creating it as a 3 line segments. So you can see in the question that there are 3 parts for the beam mainly. So in this point we have to apply a point support. In this point we have to apply the load of 120 kilonewton, and at this part we have to apply 80 kilonewton, and again at this end we have to give the support. So it should be designed as 3 segments so that all this point can be covered. So that is why I have been modeled this as a 3 line segment part. So now we have to dimension it. So click on this dimension. Okay, this is the odd dimension point. So click on odd dimension. Then first you have to select this line, and this line segment should be, you have to edit here. Okay, here you can edit, and the dimension for this first line segment is 3 meter. So I am providing it as 3. Then click enter. So the first line segment is 3. The last line segment is 4.5. So it is given in the question. it is 4.5. Then again click enter. Total dimension is 14 meter. So I am selecting this point to this point, and the dimension is 14. So now this part is 3 meter, this part is 4.5 meter, and the total span becomes 14 meter. So I have completed the dimensioning. Now I have to exit from this sketch. So for that you have to click here done. You have to click here done. So when I am clicking done, the part has been created for analysis. Okay. So next you have to go to the module property. Okay. So selecting property module, first we are creating the material. So in this property module we will be creating the material and assigning that particular material to this part. Okay. So first of all we have to create the material. So click on create material. The material to be, let the name be steel 1. And while looking into the problem, it is given that the Young's modulus is 2.1 into 10 raised to 11 Newton per meter square, and the Poisson's ratio is 0.3. So both of these are the mechanical properties. So click on mechanical. In that elasticity, click on elastic. There you can add the Young's modulus value. So it should be 2.1 E11, and the Poisson's ratio to be 0.3. Okay. 2.1 10 raised to 11, it is written as 2.1 E11, and the Poisson's ratio is 0.3. Then click on OK. So now your material is ready. You can check in this material manager. The material steel 1 is ready. Next you have to create a cross section. You have to create a cross section, and the cross section is given as 0.2 into 0.4 square meter. It means that horizontally it is 0.2 meter and vertically it is 0.4 meter. So here you can create profile, or you can create the section over here. Create section. Okay. So click on create section. Section 1, rectangular section. I am naming it as rectangular section, and it is applying to a category beam. Don't forget to select this beam category, and the type should be beam. So click on continue. There you will be asking about the profile name. Actually it can be created here. Also another option is you can create it over here also. Okay. So if you have already created by creating a profile over at this point, it will be listed over here. If you have not created, you can create it directly from here. Create beam profile. Profile 1, rectangular profile. Name of the profile should be rectangular. Click on the rectangular. Click continue. Here A, it is the horizontal dimension, and B is the vertical dimension. So the horizontal dimension is 0.2 and the vertical dimension is 0.4. So click OK. So the rectangular cross section that you have created here is listed over here. Then click OK. Okay. Then we have to assign the cross section to this beam. So that is the third option, assign section. So click on this assign section. You have to select the entire module, entire part. click on done, and it is asking that which cross section has to be assigned to the selected part. So we have to select this rectangular section and click OK. So now the part has been assigned with the section or rectangular cross section which we have created earlier. So click on done. Then next we have to assign beam orientation. So in this property module we have to carry out 4 basic steps. First we have to create the material, then create the rectangular cross section or section, then assign the section, and the last step is assign beam orientation. So click on assign beam orientation. Again select the entire part, click done, just click enter, again enter. Okay, so the assign beam orientation is completed. Next you can go to the next module, that is assembly. Here you have to create a part instance. So click on the first option, create instance. Parts, it is beam which we have created earlier. The name of the part is beam 1. Make it independent, then click OK. So now the part is ready with the assembly module. Again click on step module, create a load step. It is static general. We are carrying out a static analysis, so it is static general. Click on continue. OK. Next you have to create field output. Create field output, continue. In this we have to specify what all are the results that you are interested. So in the question we are expecting the results for maximum displacement, maximum stress, strain, and maximum reaction force. So all these 4 results we are interested. Okay, so for that we have to specify the results we are interested. So for that, click on field output. You have to create a field output over here. Click on that create field output, then the dialog box open. Click on continue. So in that you have to specify the stress. Stress is 1. Again we are interested in strain. Again we are interested in force or reactions. So in that we are interested in reaction forces. Next we are interested in displacements, right? So we have to specify the displacement also. So here the displacement. U, the translations and rotations. So click on the U. U is the displacement actually. Depending upon our selection, it will be listed over here. Okay. So for all these results we are interested, click on OK. Next you have to go to load. You have to go to the load module. In that you have to specify the total load acting on the beam. So I am creating the load. It is a concentrated force. It's actually a point load. It's a concentrated force. So click on the concentrated force, then click on continue. It's a mechanical type of load. So click on continue. Here it is asking at which point we have to create the load. So I am selecting this point. You can see that in the question. At this point C, we can see that a 120 kilonewton is acting downwards. 120 kilonewton is acting downwards. Click on this point. Click on done. So it will be asking what is the value or magnitude of the force. So this component force 1, it is actually CF1, component force 1. It is the force acting along the x direction, and CF2 is the force acting along the y direction. Okay, so if you are giving 120,000, 120 kilonewton is actually there, so we have to specify it as 120,000 Newton. Okay, if you are applying like this, it will be along the positive direction. That means it will be pointing upwards. So for that, so if you need the load to the downward direction, we have to specify a negative over there, so that the load will be pointing downwards. So click on OK. So now you can see that at this point C, we are having a load of 120,000 Newton. So again you have one more load of 80,000 Newton or 80 kilonewton. That also we have to specify at the point D. So again you have to create a load. It is again a concentrated force. Click on continue, select the point D, click on done, minus 80,000 Newton. Click on OK. So both of the loads were defined. Next, you have to create boundary condition. So click on this boundary condition, create boundary condition. You can see that this is a simply supported beam. Okay, simply supported beam means that here at this point X is restricted, Y is restricted, but at this point the rotation about the Z axis is not restricted for the beam. Okay, click on the displacement bar rotation. Okay, so click on continue, where you have to select at this point and at this point. Okay, so if I am selecting this point, after that I am going to select this point, then the selection of the previous point was disappeared. You can see that. So for multiple selection, you have to click or press shift and then click the next point. Then only multiple selection will be occurring. After selecting the 2 points, you have to click done. So here U1, it is restricted as 0, U2 is again restricted as 0, and R3, that means the rotation about that particular point, is not restricted. So I am leaving it as it is. Again then click OK. So now you can see that 2 points were restricted with the given conditions. Okay, so now you can go to the mesh module. So click on the mesh module. There you have to assign element type. Here you have to assign element type, because in the result section it is asking the element name, which element you are using, what is the size of the element, how many number of elements are there, total number of nodes. So here click on the assign element type. So click on assign element type. So click on assign element type, then select the entire thing, click on done. Now you can see that the family is beam and the element library is standard and the name of the element is B21. Okay, you can see that here the name of the element is B21. It's actually a 2-noded linear beam. Okay, so then click OK. Next, you have to divide the entire beam into finite elements. So for that we have to split these edges. After that we will be going to the meshing option. So in order to that, click on seed edges, select the entire region, click done. Here it is actually asking which type of method you are using for dividing this entire part. So I am selecting it as by size, and I am giving the element size as, let it be 0.1. okay, 0.1, and I am clicking OK. So now you can see that how we are going to divide the entire elements, entire beam into finite elements. So you can now mesh. So this is actually the mesh part instance. Click on the mesh part instance. OK to mesh. Yes. So now you can see that small elements is visible. Okay. Then go to the job module. Click on job module. Create job. Let it be the name as job 1. Continue. Click OK. Now click on submit from the job manager. You can see the job manager over here. So click on job manager. Click on submit. Now you can see that the entire analysis is been submitted for analysis. Now the data check will be running, and just wait patiently for the results to be shown. Completed successfully. You can see over here. So your analysis has been completed. Now click on the results. Okay. Now click on results. Okay. Now you can see that the location is the working directory, ABAQUS experiments, experiment 1, job 1, which is the job which we have created for analysis. Okay. So this is the S means stress. Okay. Now this is actually showing the stress. So now you can see that how the stress variation throughout the beam is shown. So if you want to check the displacement, you have to select U over here. So this is the magnitude, and you can see that the maximum magnitude is 3.55 into 10 raised to minus 2. So if you want to check the reaction force, click on RF. So now you can see that the maximum reaction forces are at these two ends, and the strain E is the strain. You can see this maximum strain is occurring at this portion. Finally, you have to generate the report files. Okay, so I will show you how to generate the report files. So click on a report. In this visualization module, there will be an option called report menu. So click on that report field output. So click on unique nodal. Click on unique nodal. Okay, in that we are interested in maximum principal stress, principal strain. This E is the strain component. Then the reaction force, magnitude. Then stresses. Then displacement, maximum magnitude of the displacement. Okay. Now go to setup. In that setup, you have to select. This will be your default working directory, and you can select a name as ABAQUS Beam 1. Then click OK. Click on OK. Now you can see that in the working directory, you can get a report file which can be opened up with the help of a notepad. So in that, the entire analysis has been reported over here. So you can see that this is the node numbers. So you can see how many nodes are there. Total 141 nodes are there. Number of nodes is 141, and number of elements will be 1 less than this. So the number of elements will be 140. Hope you can guess why it is. And now the results. Maximum value of displacement, it will be maximum value of displacement, maximum. So you can see that it is actually a reaction force. The order is reaction force, U is the displacement, E is the strain, and S is the stress. Okay. So you can see that the reaction force maximum is 120 into 10 raised to 3 Newton, and it is at node 1. The maximum displacement is 35.536 into 10 raised to minus 3 meter. This is the maximum value of strain, and this is the maximum value of stress. All these values are actually you are interested, so you have to update in their respective fields. Okay, now you can save the file save in the experiment 1, which is your working directory for this experiment. Okay, so you can select the you can specify the name beam 1, and you can see that the format for this analysis is .cae. So click on OK. Now the entire analysis has been saved. So thank you guys. Hope you all watched this carefully. Practice yourself. Thank you.